Hey everyone, it's Karen here with Gold Bio, and in this video I'm going to talk about the importance of using a kinetic curve for bioluminescence imaging. I'll talk about what a kinetic curve is, why they're essential for imaging, and then I'll talk about factors that impact bioluminescence signals. Okay, so let's just dive into what a kinetic curve actually is when it comes to measuring luciferase activity for your experimental model. The kinetic curve allows you to identify the time point where peak emission and signal plateau occurs. This information you get from the curve allows you then to find the best time point after you've injected your substrate to actually image your subject. When doing imaging, the curve is generated by taking a series of measurements that measure signal intensity, and it occurs over multiple time points, plotting that intensity in relation to time after injection. Results from your series of images will be plotted where relative light units will be represented on the y-axis and time after substrate injection is represented on the x-axis. Some imaging acquisition programs will plot the kinetics based on percentage of light intensity versus time rather than the relative light units on that y-axis. But ultimately, the kinetic curve provides a way for you to identify the most optimal time to image your subject. So let's talk about why the kinetic curve is actually essential for bioluminescence imaging. The biggest reason is that there's a lot of factors that impact the kinetics of your bioluminescence signal, and since each experiment has its own unique setup, such as location or tumor size, it's critical to identify the best time point for signaling in order to maintain reproducibility and accuracy. There are so many different factors that can impact bioluminescence signaling, and I'm just going to list a few here, but don't let this intimidate you. Because if you take everything one step at a time and you do your kinetic curve, you're going to be sure that your experiment is optimized and reproducible. So factors that impact bioluminescence signaling include tumor location. For instance, emission could take longer if you're imaging a tumor in the brain. Another factor is tumor size. Cell lines that you use for your xenograft will impact signaling. Luciferin delivery method will impact. So for instance, intraperitoneal or subcutaneous or IV, those delivery methods could impact peak signaling. Different animal models will impact your signal. And then tissue depth is definitely a big one here. The substrate you use, so if you're using D-luciferin or colentrazine, or if you're using a modified substrate, that can impact signaling. And some other factors are scar tissue and tumor geometry. So all of these factors can impact bioluminescent signaling, which is again why that kinetic curve is so important for your experiment. Then the next big question is, how do you actually generate a kinetic curve when doing imaging? Generating your kinetic curve really depends on the system that you're using for image acquisition, as well as the software that you're using for analysis. Some instruments will have programs that you can set in order to generate the images for your kinetic curve, and then using software you can analyze it. I'm also going to include a link below for our luciferin handbook, and that has more details on generating a kinetic curve. There's also a section about generating the kinetic curve based on different substrate delivery methods. So for instance, if you're doing intraperitoneal or subcutaneous injection, you want to take an image every 5 to 10 minutes for up to 60 minutes. And if you're doing IV, you want to take an image every 1 to 5 minutes for up to 30 minutes in order to generate that curve. Ultimately, what I want to emphasize here is that your experimental setup is going to have a lot of differences from one experiment to the next. So that's why it's important for reproducibility to generate that kinetic curve. Below, I have that link to the in vivo handbook, as well as some other links about bioluminescence imaging. And as always, if you found this video helpful, be sure to hit the like button and subscribe for more content. And don't forget to check out goldbio.com for information and access to high quality reagents. Thank you so much for watching. Take care.